Right, so in this video, I'm going to explain quadratic inequalities. This is the important information that you need to know with regards to inequalities, any inequality. You have got less than symbols and you have got greater than symbols. If it is a less than or a greater than, then on the number line it is indicated with an open dot. It shows that it's not included. If it is less than or equal to, greater than or equal to, then on the number line it is a closed dot to show that it is included. So what I would like you to do is pause and write down these notes to start off with because you're going to need them a little bit later. The next thing you're going to need to know is how to plot a quadratic inequality on a number line. Now, it's called a quadratic inequality because we use a quadratic graph to kind of like figure out how this works. It's not actually a quadratic graph. It's more of a tool to help you figure out what's going on. But again, I need you to write down these notes. If the inequality is greater than or equal to, then what you are doing is you are shading to the outside of the quadratic. If it is less than, or if it is less than or equal to, then you are shading below the quadratic. Now that's going to make no sense to you right now, but as soon as we've done more examples, hopefully it will. So again, pause, write this down, and then we can carry on. So what I've got here on the board are 4 of exactly the same question. I've just changed the inequalities so we can look at all the various examples. All of them are going to start the same. You are going to factorize the quadratic as you would normally factorize a quadratic. So you've got x plus 6, and you've got x minus 2, and then it's less than 0. Now I'm going to draw the number line, and then I'm going to draw this quadratic. Remember, it's more of a tool than anything else. The less than symbol over here is telling me that I am shading below the line. So I'm looking at this area of the quadratic. The less than symbol without that little extra line means that I'm having a number line that's got open dots on it. And then the last thing I've got to do is figure out what are the values I'm working with. Now, it's not technically correct, but if you had to take x out of the bracket, it would be minus 6. And if you had took x out of the bracket, it would be 2. Now, it's not actually minus 6 and 2 because it's an inequality, not an equation. But we'll cheat a little bit and just pretend for a moment. So on your number line, I would indicate negative 6 and I would indicate 2. Now, what you're going to write is the answer to this as an inequality. And the answer would be negative 6 less than x less than 2, because what you are literally doing is you are writing down how it goes from negative 6 right through to 2, and that is what you've got over there. So it's going from negative 6 to 2. Now we're going to do exactly the same question to the right hand side, but this time it's going to be greater than. So again, I factorize this, and I've got x plus 6 and x minus 2, but this time it's greater than 0. I draw my number line, okay? I draw this quadratic, remember, just to help me figure out what's going on. My values are still negative 6 and 2, that hasn't changed. And it's still an open dot because it is greater than, not greater than or equal to. So that hasn't changed. What has changed is that I'm now shading to the sides of the quadratic. So I want to know, what does that represent? So this is telling me that the shaded region is less than negative 6 and the shaded region is greater than 2. So that's literally what I'm going to write. I'm going to say that x is less than negative 6 or x is greater than 2. So what I like to think of it as is if I've got one shaded region, I've got one answer. And if I've got two shaded regions, then I've got two answers. Now, the questions below this are exactly the same. It's just that the inequalities and the dots change. So what I mean by that is, here I've still got x plus 6 and x minus 2. This time it's less than or equal to 0. I draw my number line. I draw my quadratic. But now the dots are closed instead of open to indicate that the points are included. Minus 6 and positive 2. Less than means I'm shading below. Oh dear. So less than means I'm shading below. So it's negative 6, less than or equal to x, less than or equal to 2. So what has changed is the inequality, but nothing else. On the other side, I have got x plus 6, x minus 2, greater than or equal to 0. Draw my number line, draw the quadratic. Greater than or equal to means closed dots, and it means that I'm shading to the side. Still negative 6, still positive 2. But this time my answer is x is less than or equal to negative 6, or x is greater than or equal to 2. Pause, make sure you've got all of this written down. I'll do a few more examples with you, and then you've got independent work. So let's pretend these are two questions. For the first one, the first thing you always do is factorize it. So I'm going to factorize this quadratic, and I've got x minus 5 and x minus 2 greater than or equal to 0. Draw my number line. Draw the quadratic. Greater than means I'm shading above the line. Greater than or equal to means that I've got closed dots on my number line. What are my two values for x? Well, if I had to pretend that it was a normal equation, I would have said x equals 5, and I would have said x equals 2. So those are the values we're using. Put them in numerical order, so the 2 would come first and then the 5. And then you are writing down the inequality for each region. So the one inequality is that x is less than or equal to 2, or x is greater than or equal to 5. If you look at the second example, factorize again. You've got x plus 6 and x plus 2 less than 0. Draw your inequality, or your quadratic rather. Less than means it's an open dot, and we are shading under the line. My two values of x would be negative 6 and negative 2. So again, numerically, it would first be negative 6 and then negative 2. Numerically, I mean as it was represented on a number line. The shaded region is now in between the two. So you'd say negative 6 less than x less than negative 2. Pause the video, make sure you've got those copied down. On the next page are going to be questions for you to try on your own. This work comes from Maths Genie. I would like you to attempt these 14 questions. Give yourself some time to do that. While you are working, make sure that you've written down the question, factorized it, drawn the number line, worked out the various solutions. Pause at this point. Give yourself some time. When you unpause, all of the answers will be on the screen. I would like you to then mark your work, please. Right, here are the answers to the first 6. I've only done those so long because I want to explain a few things with question 7 and question 8. And then you can continue with the rest of those. So just mark these. Hopefully you're starting to get used to what happens where. If you are really, really confused, I will explain it to you when I see you again, but could you please write these down in the meantime? So pause if necessary at this point. So what I wanted you to see on question 7 is that what you had is the difference of two squares. So if I took that 100 over to the left-hand side and made it negative 100, I then have the difference of two squares, which means, although it's not really true, that x is 10 or that x is minus 10, and then I represent that on a number line. Now the same thing is going to be happening with question 8, and then question 9 onwards is just a little bit mix of everything. So I would like you to try all of those, or hopefully you have, and then you can watch the rest of this. Right, so there's questions 8 up until 12 that you can see. So for question 8 again, you have the difference of two squares. Question 9, you need to get this over to the left-hand side and then factorize it. Question 10, you factorize either using my method or any other method. So you get fractions, which is absolutely fine. Question 11 is trickier. That x squared must be on the left-hand side, so I put it there, but now I've got a negative quadratic. The minute I've got a negative quadratic, I make it positive, so I change all the signs by dividing by -1, and the inequality changes direction. This is definitely the most tricky question, number 11, and one that I do want you to write down, and I will explain it to you when I see you if it doesn't make sense. Question 12, you go to quadratic formula, or factorizing, depending on what you're going to be doing. And if you look at number 14, again, it is the quadratic formula. We get decimals of 2.38 and 4.6, but they're asking you for the integer values, in other words, a whole number. So the whole numbers between 2.38 and 4.6 are 3 and 4. If you manage to get to these questions in the lesson, that's fantastic. If you haven't, that's fine, and I will explain them to you again when I see you.